This is for Year 11 methods. We're going to look at question 3 from exercise 3L. So these are the application questions. I'm going to go through how to effectively use the calculator basically, because you're going to encounter possibly similar questions in the SAC, and you need to know how to find the key features of a graph. Okay, so this is an example where we're given an equation for the efficiency rating of a spark plug. Now, we don't necessarily need to know what the scenario is. It's just basically an equation that they give us, and we're trying to find some features of it. So we're trying to sketch a graph of E, the efficiency rating, against X, the distance from the spark plug. Okay, and X is between 0 and 1. What this is telling me is that the graph should be sketched between 0 and 1 only. Okay, and that gives us an idea of the domain. We're not looking at a domain or the x values between 0 to 100. That'll be incorrect. Or 0 to 10. We want it from 0 to 1. And this is key to understanding what our graph will look like, okay, or how we can get it show on our graphs calculator. So let's enter it on calculator and give it a try. So I'm going to go and enter on my calculator. I'm going to put on my CAS. I'm going to use the drag and drop method, so I'm not going to use the y equals menu. I'm just going to go 400x minus x squared. Okay, I'm going to plot the graph, and you'll notice, when I drag and drop, I don't really see a graph, and the reason is our x value, our x range is a bit too large. Okay, so our graph is actually between 0 to 1, which is what the question actually told us. So let's try 0 to 1, and our y, if we looked at the graph, it was quite tall. So let's try a number like 50. Okay, perfect. We can actually see the turning point, and we can see the x-intercepts if you just drag it up a bit more. Okay, so this is a good indication that we got a pretty good screen. You can also zoom out a bit just to even get a better picture. Okay, perfect. That's an even better picture. So let's get all our key features. So we'll get an analysis GSolve maximum. 0.5 gives you 100. And let's find our roots to get our x-intercepts. So we got 0, and to get the other x-intercept, you just sidestep. So go click the right click. We get, okay, let me check, 1 0 and 0 0. Okay, so I've got a good picture of what the graph actually looks like. So let's go back to the slide and draw it. Okay, so I'm gonna be using a ruler on the test. Okay, but since I'm drawing freehand, it's not going to be as accurate. So efficiency is in percentages, and x is in millimeters. So you have to include your units. Now we know it's a parabola shape. It's a frown. That's a 0, and that's a 1, and we know that that's 100. Okay, so when the gap is 0.5 millimeters, the efficiency is 100. Okay, so what value of x gives you a 0 efficiency rating? X happens to equal 0. What value of x gives you the maximum efficiency rating? Okay, the maximum happens to be at when the plate distance is 0.5 millimeters. I should put in units. Use a graph and the value of x which the efficiency rating is 70 or more. All I have to do for this question, you got to interpret. So you want the efficiency rating to be 70 or more. So it'll be wise to actually work out what the intersect is between the equation. Literally doing is, you can do this graphically, or you can do it algebraically. So if you do it algebraically, you're going to go the equation equals 70, and you're finding the intersection. And if you're doing on the main screen, which is what I'm doing now, you get an exact value. So I'm going to go interactive, advanced, solve for x, and maybe we'll put decimal because so 0.226 and 0.77 or 0.774. Let's read what the question asks again. Use a graph file to determine the values of x between which the efficiency ratings. So you can use those values. So it's between x.226 and x.773, or you can use a graphical method. In analysis GSolve. Xcal ycal. Okay, so we want a y value. We want to calculate x value when the y value is 70. Yep, so you've got put, and if I sidestep, if I click the right key, the right button, I get 0.774. So you get the same answer, but it's just two alternative ways to do it. Now, if you're asked to do exact value, you always use the solve button on the main, because that always gives you exact value. Whereas the graphical method gives you decimal values. So 0.226 and 0.774. Okay, so 0.226 and 0.774. 0.22